Hello everyone, my name is Benjamin Cole and I'm a student from International Bachelor Program in Informatics. Today I'm going to share my reflection of machine learning course. Before explaining the course, I want to start with why I chose this class. I chose machine learning because AI has become more important in many fields, and I did not want to only use AI without understanding how they work. I want to know what happened behind the answer, how data is used, how a model learns, why prediction can be correct or wrong, and how people decide whether a model is trustworthy. So, the main idea of my presentation is simple. Machine learning turns data into decision. Um, Through this course, I learned that machine learning is not just use a program; it is a structured process that connects data, algorithms, evaluation, and real-world problem solving. The course covered the main area of machine learning. In the beginning, we learned the foundation, including introduction, decision tree, k-nearest neighbors, and linear regression. These topics help us understand basic prediction and classification. Then we moved to a better model and evaluation topics, such as preparation, logistic regression, regularization, and model evaluation. These parts were important because they show us that building a model is not enough. We also need to check how well it performs. After that, we learn more advanced models, including support vector machines, kernel naive bias, um, ensemble method, and learning theory. These topics help us compare different algorithms and understand why different problems may need different models. Finally, the course also introduces AI application using neural network, deep learning, unsupervised learning, and reinforcement learning. Overall, the course gave us a broad view of machine learning develops from basic model to modern AI system. The course was taught through lectures, mathematics ideas, coding practice, assignments, and a final project. The lectures help us understand the concept beyond each model. The mathematics part help us explain why the algorithms works, such as how a model reduce errors or improve its predictions. The coding practice help us connect the theories to actual results. The assignments were also an important part of the course. We practiced decision tree, linear regression, perceptron, logic regression, evaluation matrix, SVM image classification, ensemble method, naive bias, and DDGP reinforcement learning. These assignments made the course more practical because we have to observe results, compare models, and answer questions beyond what we tested. The final project also encouraged to think beyond the classroom. It asked us to apply machine learning to real tasks, which helped connect the course context to real world problem solving. The course matters because machine learning is now part of many technologies people use every day. For example, search engine, recommendation system, image regression, flaw detection, mathematical tools, and many AI applications all depends on machine learning ideas. If students only know how to use those tools, they may not understand their limitations. This course helps us understand the logic beyond this system. Another reason this course matters is that the context several important skills together. Sorry, it connects several important skills together. It connects mathematics, programming, data analysis, and critical thinking. Students do not just learn one tool, they learn how to approach a problem, choose a method, test a result, and improve it. For students preparing for AI, data scientist, software engineering, or automation related fields, this course provides an important foundation. So, what I learned for this course, I can summarize my learning into these three main parts. First, I developed practical skills for working with data and models. Second, I understood the basic workflow of machine learning from defining problem to evaluating a model. Third, I learned how different machine learning method you can apply to real life problem. I will explain those three parts in the next slide. Skill I learned. This course helped me develop both technical skills and thinking skills. For technical skills, I practice data preparation, feature selection, trend trend test, split, and model evaluation. These skills are important because the quality of model depends on not only on the algorithm but also on how the data is prepared and tested. For thinking skill, I learned problem framing, model compression, error analysis. This means that machine learning is not just coding. It also requires asking the right question and understanding the meaning of the result. One important lesson of me is that accuracy alone is not enough. A model may have good score, but it still fail in some limitations. So we need to think about reliability errors, whether the model can work on new data. This slide shows the basic workflow of machine learning. First, we define the problem. We need to know what we want to predict or classify. Second, we prepare the data. This includes collecting data, cleaning it, and selecting useful features. Third, we train the model. The model learns patterns from the training data, of course. Finally, we evaluate and import and improve the model. We test it on unseen data and check where it makes mistakes. This workflow helped me understand that machine learning is not just a simple step, it is an interactive progress. A model often needs to be tested, adjusted, and improved before it becomes useful. The course also helped me understand how different machine learning methods can be used in real life. Regu- uh, regressions, regressions can be used to predict prices, demand, trend, or medical values. Classification can be used to detect swamp, classify risk, or identify categories. Unsupervised learning can discover hidden patterns or custom group when there are no labels. Ensemble learning can improve prediction stability by combining multiple models. CNNs and deep learning are useful for image recognition, object detection, facial recognition, and medical image analysis. Reinforcement learning can train agents to make decisions through rewards and actions, such as in games, robotics, and control systems. This example shows me that machine learning is valuable because it can be applied to many different problems. Before taking this course, I mainly thought of AI is just a tool that giving answers. However, after this course, I understand AI and machine learning in a more structured way. I learned that a machine learn I learned that machine learns from data, but it can also make mistakes because of noisy data, missing features, overfitting, or poor evaluation. Most important change for me is that now I think more critically about model results. Instead of only asking whether a model gives an answer, I ask whether an answer is reliable, whether it can generalize a new data, and whether the model is sustainable for the problem. This course helped me connect theory, coding, um, assignments, project, and real world decisions into one complete learning experience. To conclude, I think this machine learning course was valuable because it helped students understand modern AI from the inside. It did not only teach us name of algorithms; it taught us how to think with data, how to test models, and how to connect machines learning methods to real application. Thank you for watching my course reflection.